Alright, these are today's notes, 07 notes on distance formula. Your objectives, you will be able to use the distance formula to find the distance between any 2 points. Now, distance formula could be used in several different cases. Anything that involves distance, whether it be in a video game or you're creating a mathematical model, distance, to calculate that distance, you could use the distance formula, knowing which the 2 coordinates, the location of those 2 coordinates are, and on the scale of which you want to measure those distance. So, several ways you could find distance between 2 points. First, you could use a ruler to measure it out. That's one way you could always do things. For example, like you see here, the distance between B and C, well, you know it's just 1, 2, 3 boxes. However, if we're using a ruler, we want to use the ruler for everything. So we put the ruler there, and we see it's a distance of 0, 1, 2, 3 boxes. We can rotate that ruler around. There it is. So you go rotate it around to go from B to A. You see that the distance between them is 3.5, and you can rotate it between A and C and calculate that out too. And you'll see that's around 6.5 based on this ruler. However, I changed the size of the ruler, so that's why I got messed up a bit. A little bit tougher online and in person. Well, anyway, so we could use the Pythagorean theorem also, which you learned about in middle school, to find the diagonal distance. So if you know if it's a horizontal distance or a vertical distance, you could just count the boxes. However, diagonal boxes, or if you have a line that's diagonal, it's a little bit harder to count the boxes. So we could use Pythagorean theorem to find out that diagonal distance. For example, we have this problem here. We see that between A and C, there's a distance of 4. Because A is the location of 5, 1. That means 5 to the right, 1 up. And C is 1 to the right, 1 up. So to find the distance between A and C, you take the 5 and you subtract the 1 in the x-axis to find the x distance, which is 4. Now the reason why I chose x distance because it's a horizontal line. With the vertical line, I'm going to worry about the y values between B and C. The height of B is 4, the height of C is 1, so 4 minus 1 gets you 3. So there's a distance between B and C, there's a distance of 3. Let me write those in. So you have a distance of 3, and you have a distance of 4. Now that you know those distances, you can plug those 2 numbers in to the Pythagorean theorem, a squared plus b squared, and that's how we're going to find out c squared. So I'll zoom out real quick. Four squared plus 3 squared equals c squared. So you know that's 16 plus 9. That's just c squared. 25 equals c squared. Now to get rid of the squared, you take the square root like we talked about in class. So you take the square root of both sides and you get c equals 5. So the distance from B to A is 5. So that's another way you could calculate the distance. Keep in mind, remember how we found the distance between C and A? We counted the distance of A from 0 and then we subtracted the C value, which is the C value is the distance from 0 to C. There's another one you could practice with finding that distance using the Pythagorean theorem. We could find the length of that and the length of that, and then we can make that, call that a C. So this is 1, 2, 3. This is 1, 2, 3, 4, 5. Say 3 and 5. 3 squared plus 5 squared, that gets you 9 and 25. 25 plus 29, sorry, 25 plus 9 gets you 34. So this length is 34, which is the square root of 34. Because that's a squared, that's b squared, equals c squared. And so we have to take the square root to find that distance between a and b. So this is a 3, 5, square root of 34 triangle. One you could practice with. Another. Alright, now we're going to move forward here. We're going to derive another formula based on the Pythagorean theorem formula. This formula is going to be called the distance formula, and this is the formula that we're going to be working with today quite a bit. So if we're looking at this, let's square things up a little bit better. Zoom out. Yep, we can go read that. Okay. So it says A, draw in our right angle and label the sides A and B. Next step, we know that the distance between two x values is x2 minus x1, like we were talking about before. Remembering the distance from A to C, that's what we're talking about here. So we're subtracting that distance, and the distance between the two y values, getting that height. That's the y2 minus the y1. Then we're going to plug those in to the Pythagorean theorem. So it's going to look like this. You have c squared is equal to parentheses a squared, which is the x2, minus the x1 squared, then plus y2 minus the y1 squared. Now to get c all by itself, we take the square root of both sides, and we're going to get our formula here. C equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's the distance formula, like you see here. So let's zoom it back in. So that's the distance formula. The distance between 1 and 4, the distance of between A and B, you have 1, 4 and 6, 7 are your two coordinates, so we plug them in. The A value is going to be our x1 and y1. Our B value is our x2 and our y2. So we plug them in. x2, 6 minus 1, 6 minus 1, plus 7 minus 4. And we crunch them out. Alright, so critical thinking here. Can we have a negative distance? No, we cannot. We cannot have a negative distance. Distance is always positive, including 0. If we took the distance of a line segment AB and the distance of a line segment BA, would their distance be different? So if you go one direction, then you do another. So if you're starting at one end of a block in a neighborhood, you walk to the end of the block, you turn around and you walk back and wind up in the same exact spot, did you go the same distance? Of course you did. So the segment BA and the segment AB, those two segments are the same distance. If our distance of line segment AB is 0, what does that tell us about our 2 points? Well, that tells us that they're the same exact point. If there's no distance in between them, that means both point A and B are the same exact point. Alright, let's practice a couple of these distance formula equations here. Or find the distance between two coordinates using the distance formula. So, let's do it. So my 5, bring it down a little bit more. My 5 is the x1. My 4 is the y1. Negative 6 is x1. So So that's going to be x2 and y2. So the first coordinate gets the little 1's in the bottom right hand corner, and the second coordinate gets the little 2's. Then we just got to plug them into the formula. So to find that distance, we do the square root of x2, which is -6, minus x1, which is 5, squared, plus y2, which is 0, minus y1, which is 4, and we square it. -6 minus 5 gets you -11, so we -11 squared, plus 0 minus 4 gets you -4. -4 squared is 16. -11 squared gets you 121, so we have 121 plus 16. This is all in the square root. So we got the square root of 137. And then we got to put that into the calculator. So the square root of 137 gets you 11.705. So it'd be C. Let's try another one here. Number 3. A little bit bigger. And we'll do a different color, we'll do blue. So the first coordinate gets the 1's, x1, y1. The second coordinate gets the 2's, x2, y2. And then we plug them into our formula here. So we do square root, x2, which is -6, minus x1, which is 5, squared, parentheses y2, -1, minus y1, which is -8. Notice here we have two negatives. That's why we practice identifying signs in the beginning of the year. When you have two negatives, that really makes a positive. So we can fix that right now. Here we go. Square root. -6 minus 5 gets you -11. And it's going to be squared. Plus -1 plus 8 gets you a +7. So it'll be +7 squared. -11 squared, that gets you 121. 7 squared gets you 49. 121 plus 49 gets you 170. And the square root of 170 is 13.038. So number 3 is also C. Why don't you try number 4 on your own first? We'll see if you can do it on your own. I bet you can. So x1, y1, x2, y2. We plug them in. y2 is -7, minus y1, which is 6, squared, plus x2, which is -1, minus y1, I'm sorry, x2 minus x1, minus 4. The x's and y's are interchangeable. Doesn't really matter if you do y's here and x's here, or you do x's here and then the y's here. Not the end of the world. -7 minus 6 gets you -13. Squared. And -1 minus 4 gets you -5. -5 squared will be the other guy. Remember order of operations, so you gotta do your exponents first before addition. So -13 squared is 169. And then -5 squared is 25. 169 plus 25 gets you 194. And the square root of 194 is 13.92. So number 4 is D, 13.92. Here's another one you could practice with. And we're going to skip a couple because I want to get to here. Look at number 11 here. This is the same concept. We have a line. And we got to find that distance of that line. It's a little bit different because it's a different presentation, but it's the same idea. We first have to do this extra information. From our origin, we can find our coordinates. We could always put a map onto anything to create distance. So from that green point, that origin, it's one to the right, one up. So this first coordinate is 1, 1. The other coordinate is negative 5, 5. It doesn't matter which one you call x1, y1, whatever one's the first coordinate, and which one's the second coordinate doesn't matter. I'm going to label them just like that. And then it's the same procedure. To find the distance, you do the square root. y2 minus y1, so 5 minus 1 squared, plus x2 minus x1, so negative 5 minus 1 squared. 5 minus 1 squared is 16. Negative 5 minus 1 gets you negative 6, and negative 6 squared is 36. I should be a little more clear. 5 minus 1 is 4, and 4 squared is 16. So that's how I got that 16. 16 plus 36 gets you 52. And the square root of 52 is 7.211. And then it looks like it's an irrational number. It goes on and on. Let's squeeze in one more like this. Let's try number 12 here. So from this purple dot, we know it's 4 to the right, 1 up. So it's the coordinate here is 4, 1. And this one is 0, 2. Those are my two coordinates. x1, y1, x2, y2. I like labeling it just to help identify what is what. I recommend you do the same. So you do square root, y2, which is 1, minus y1, which is 2, squared, plus x2, which is 4, minus x1, which is 0. And then simplify it. 1 minus 2 gets you negative 1. Negative 1 squared is positive 1. 4 minus 0 is 4, and 4 squared is 16. 1 plus 16 is 17. So we have the square root of 17. And that gets you 4.12. And 3, dot, dot, dot. Looks like it's an irrational number. So 4.123, dot, dot, dot. All right. One you could practice with on your own. And even though I don't say it, classwork is 07 CW1 distance formula, and homework is 07 HW1 distance formula. All right, have yourself a good night. If you have any questions, email me or come next show. We'll be happy to help you out. All right, have a good night.